Let's look at solving a system of inequalities graphically. Here we've been given two different inequalities, x plus y less than or equal to 2 and 3x minus 2y greater than or equal to 6. We need to know where each inequality individually will be true, and then we want to look at where the two things are overlapping. That will be the solution for our system of inequalities where both things are true. Look at this first inequality. If we pretended that it said equals, then we could find our two intercepts by putting 0 in for x. That would give me y equals 2. 0 in for y gives me x equals 2. So I have as intercepts for that one 0, 2 and 2, 0. Now, if we substitute 0, 0 in to see if it's true or false, since the line misses 0, 0, 0 plus 0 less than or equal to 2 is true. So this is a true statement for this inequality. Now, I've already drawn here x plus y equals 2. And 0, 0 here is where it would be. So when we change it to an inequality, we're going to shade this side. Let's make that change, switching it from equals into being an inequality less than or equals. And you can see that we have shaded the side of the line where 0, 0 was, since it was true. Now, I'm going to take that away. Let's remember that it's below the line that we have shaded. You may want to draw little arrows pointing at the area that you've shaded. But I'm going to take that away and change it for now back to being just an equals. Now, let's go back and look at the second inequality. The second inequality, if we put 0 in for x and we pretend that this says equals, we would get a y-intercept 0, negative 3. If we put 0 in for y and pretend that it says equals, we would have an x-intercept of 2, 0. So now on our Cartesian plane, let's now graph that as if it were just a line and it just said equals. When I put 6 in for our constant value, you can see an x-intercept here at 2 and a y-intercept down at negative 3. So the blue line, that is how the bottom, in this case, equation looks. But if we make it an inequality, when I test with 0, 0, if we put 0, 0 in to the original inequality, 0 minus 0 greater than or equal to 6, that's going to be false. So where we're going to want to shade away from 0, 0, it's this side of the blue line that will get shaded. Let's change this from an equation to being greater than or equals, and you can see that we have shaded away from 0, 0 for the second inequality. Now I'm looking for where these things overlap. We've got, for the second inequality, this part being shaded. And remember, for the other inequality, it was below the line here that we wanted to shade. You can already tell the part that's overlapping is going to be the part that's here. But let's change this again to being an inequality so that we can see what our solution should look like. The part that is true for both of them is the part here that's kind of purple colored. That was below the first inequalities line and below the second inequalities line, and here is where they're overlapping. So this is the area that we would be shading for this system of inequalities. Let's look at another system of inequalities to solve graphically, only this one has a higher exponent attached, so maybe it's going to be a little bit harder. First, individually looking at the two inequalities, the top inequality, y less than or equal to 2, if we pretended that that said y equals 2, it would be a horizontal line. So y equals 2 is this horizontal line. Now, where things that are less than or equal to that, it includes the line, and it is also going to be stuff that would be below the line. So when we make it y less than or equal to 2, it would look like this. Below the line is true for y less than or equal to 2. Now I'm going to change it back to equals so that it is easier for us to see what takes place with the second inequality. On the second inequality, y greater than or equal to x squared minus 1, that square makes this a parabola, and the parabola has been shifted down by 1 place. So now first, let's graph just y equals x squared minus 1. There's the parabola. You can see that everybody has been shifted down by 1 place. Now, just like before, what I want to try to do, I want to test with 0, 0 to see if I want to shade inside the parabola or if I need to be outside of the parabola. So when we test with 0, 0, you would end up with 0 greater than or equal to -1, and that's true. So it's inside of the parabola that we're going to want to shade. If we look just at the parabola, changing this from an equals to a greater than or equals, you see that it is inside that we needed to shade. Now, where are both things going to be true? It's inside the parabola, but below our red line. So the places where they overlap inside the parabola, but under the red line, it would look something like this, where the area is purple with the shading. Inside the parabola, but below that line, that's where they're both true. Now, this is what is called a bounded region because it's closed in on every side. If you had an opening somewhere, it would be called unbounded.